Okay, now we come to the network analysis. Analysis to how to solve the large network, which difficult to apply only voltage divider, current divider, or maybe it's not possible to find equivalent resistance. Okay, not series resistance, parallel resistance that you can calculate the equivalent resistance, right? But if the network is complex, what is the method to solve? Okay, so we will talk about chapter 3 of our reference book, and I will talk about no voltage, only no voltage for this hour. Okay. For node voltage analysis, okay, the step is we select one reference node. Select one reference node, any node for the reference. Okay. For you convenient, okay, any node. For example, this circuit we can take node C. This circuit we take VC like this as a reference node. Then now we remain n minus 1 node, right? We remain n minus 1 node. And then we apply KCL at each node. KCL at each node. KCL at each node. So if you have the voltage source, if you have voltage source in the circuit, we will take it as dependent variable. Okay. And if the node is not connected to the voltage source, the voltage will treat as independent variable. Okay. The voltage. If the voltage source is here, for example, right, 5 volt, it means we know that this is 5 volt, right? It's dependent variable. Okay. If there is no voltage source, if no voltage source, this is VA, we unknown. VA, we don't know VA, right? Okay. We don't know VB. And for node voltage analysis, we use KCL in the form of node voltage. We formulate the equation by KCL in the form of node voltage. For example, all node voltage and branch current here. This is reference node, and we remain only maybe 2 nodes, right? This node and this node. Okay. This is node 1. This is node 2, right? So if we know I1 is 10 milliamp, I2 is 50 milliamp, right? R1 is 1K, R2 2K, R3 10K, R4 2K, like this. For node 1, KCL at node 1. This means that I1, no solution, right? Okay, we need to do it. I1, so in case the current flow in is positive, right? Flowing out is negative. Flowing out is negative. I1 minus IR3 minus I of R2 minus I of R1 equal to 0, right? This is first equation. For node 2, the current flow out is minus. So minus I2 plus IR3, right? IR2 plus IR2 and IR4 and plus IR4 equal to 0. Okay. Then we can substitute IR3. This is V1 and this is V2. So IR3 equal to V1 minus V2 divided by R3. Right? The voltage across R3. Similarly, IR2 is V1 minus V2 divided by R2, like this. And what is IR1? IR1 is V1 minus 0 divided by R1. Okay? So we can substitute all parameter I1 10 milliamp, right? 10 milliamp minus V1 minus V2 divided by R3. R3 is 10K, right? And then minus IR2 V1 minus V2 divided by R2 is 2K minus IR1 is V1 divided by 1K equal to 0. Okay. Right? We will have V1 and V2 as unknown. V1, V2 as unknown. This is equation 2. Now, come to equation 2. Minus I2 is minus 50 milliamp. Right. Then plus IR3. What is IR3? IR3 V1 minus V2 divided by R3, right? V1 minus V2 divided by R3 plus IR2 V1 minus V2 divided by R2. And then IR4 is V2 divided by how much? How much the current from here is V divided by R4, which is 2K. So we have two equations. we have two equations with two unknown, and we can solve these two equations to unknown, and we get V1 and V2 value, right? Okay, we get the value of V1 and V2 here. So I'm not going to solve this now, right? Because we can rearrange, right? We can rearrange into a simple equation, and then we solve these two. For example, if we multiply 2, if we multiply 2 by 3, then go into equation 1, what happens? This will be 2, right? 2 minus 2 V1 minus V2 minus V1 minus V2, and then minus 2 V1, okay, equal to 0, right? 2 minus 2 V1 plus 2 V2 minus V1 plus V2 minus 2 V1 equal to 0. We have V1 here, V1 here, V1 here. So minus 5 V1 plus 3 V2 equal to minus 2, for example. So we can rearrange the equation into simple one, right? Similarly for equation 2, and we solve two equations, two unknown. Okay, we get V1 and V2. I leave it for you here, right? You check whether if you formulate the correct equation. Next step is to solve is correctly, right? So if we formulate the wrong equation, exactly we get the wrong answer, right? Okay? If you formulate the correct equation, maybe we solve to the wrong answer. Okay? There's two steps, right? To get your equation correctly first. Okay? Do it slowly, right? You can do it slowly. Okay. To formulate the equation. And we call this method as node voltage analysis. Okay? Node voltage analysis. Do I need to solve until yes or no? Right? You can do it later. Okay, let's see this example also. Here this is a reference node and this is VA. Now call VA. We can call VA, VB. Or V1, V2. It's up to you if there is no notation from the equation. Okay, we call VA and VB. Okay. And this is a known value. And our node equation, node A is IA flowing in, right? Minus I1 minus I2 equal to 0. And this is IA. And what is I1? I1 is VA divided by R1. I1 is VA divided by R1. So we substitute I1. And what is I2? I2, this direction we use VA minus VB, right? the voltage across R2, VA minus VB, divided by R2, so we have this equation. Okay. Then next, for VB, for node B, so flowing in is positive, right? Flowing in is positive. So I2, this is I2 plus IB is here, minus I3 minus I4 equal to 0. Okay. For node B. And what is I2? Same, right? I2. VA minus VB divided by R2. Okay. We need to be very, very careful about the direction, right? And the sign, right? And the sign of our parameter. Okay. IB flowing in positive. So it's IB. I3 is VB divided by R3. I4 VB divided by R4. So we have these two equations. Then we substitute the known value. So we know IA, we know R1, we know R2, right? We know R2, we know IB, right? IB, yeah. We know IB, we know R3 and R4. How many unknown remain? How many unknown? How many unknown? 2, right? 2 unknown, VA and VB. So we can solve for VA and VB. Okay. This method, we can solve for VA and VB. Right? Or we can further arrange this 1 multiplied n minus VA divided by R1, 1K. Minus VA minus VB divided by 500 equal to 0. That is this equation, VA minus VB divided by 500 plus 2 multiplied minus 3 minus VB divided by 2.2K minus VB divided by 4.7K equal to 0, like this. And we can rearrange into this form and then this form, and we solve VA and VB here, right? Finally, we know that VA is 1.667 volt and VB is 2 volt. So the objective of solving the circuit by nodal analysis is to solve for node voltage. Okay, we solve for voltage. We apply KCL, but we solve for node voltage. After we know the voltage, we can calculate. After we know the voltage of all nodes, we can calculate the current later, right? Then if we know VA, we can solve for IA, right? we can solve for IA because VA, if we know VA, IA is VA divided by R1, right? We can solve for I2 also, right? If we know VA and V2, we can solve for I2. So we can solve for the remaining unknown value, right? Okay. So first, we don't care about the current, but we try to form the current into the voltage form, right? This is a voltage. Okay. Any questions? Next step. Like difficult now. So it's become complex if we have the voltage source. Okay. We say similar way, but we know the voltage of some node already. We know, so we don't need to solve for it. Right? For example, we know VA in this case, we have one reference node. We have one reference node. And the remaining node is 3. But this is we know, right? Because this is the voltage of the source, right? VA equal to VS in this case. Okay? And this is VB and VC. So in this case, we solve for VB and VC only, okay? So we need 2 equations, right? We need 2 equations. For example, if we solve for node B, the current flowing in is positive, right? Okay. I1. This is I1, and this is let's say this is IR2, right? IR1, and this is IR3. What is IR1? I of R1 is VA minus VB divided by R1, and IR2 is VB divided by R2, right? And IR3 is VB minus VC divided by R3, and by KCL with this node, we get IR1 minus IR2 minus IR3 equal to 0. And we substitute, we get this. This is IR1, IR2, IR3. And we know that VA is VS, so we know VA is VS. For node C, similarly, for node C, we have IR3 and IS flowing in IS, and we flow out IR4. Okay. So flowing in is IR3 minus IR4, right? IR4 plus IS. So substitute IR3 is VB minus VC divided by R3 minus VC divided by R4 plus IC equal to 0. So we get this equation, right? So right now we come to two equations, two unknown, right? So, what are the known values? Vs we know, R1 we know, R2, R3 we know, R3 we know, V7 we know source value. So, with two equations, two unknown, we solve for Vd and Vc, right? Similarly, we just rearrange the equation, or maybe we can rearrange equation into this form. It's two equations, two unknown, right? Then we substitute the value of the known parameter that we solve. So, solving the equation, so it's depends on your convenience. It's up to you. Right? So, okay. But maybe just make it correct. Okay? You can use any method, right? Any method. To solve two equations, two unknown, right? So it's up to you. Okay, this is example. This is the last example. Okay. This is sample and then finish for today. Okay, so next time we talk about mesh analysis. Okay, we go into mesh analysis. Maybe the exam up to mesh analysis from midterm. Usually. Okay. So let's see this example. How to solve this circuit. We don't know the current I. We know the voltage. With this circuit, we know V3 minus V2 equal to the voltage source, right? Equal to 3. We know Vt minus V2 is equal to 3 volts, right? But the current I is the difficult parameter. So, okay. So I will go a bit fast. R1 is 2 ohm. And maybe I skip some step, right? Because now we will have some good understanding and 4 and 3 ohm. This is 2 amp. Okay. So we have node VA. We have node V2 and node V3. So I will denote the current. This is IR1. This is IR2. This is IR3. And this is IR4. So if we apply KCL at node 1. So flowing out, if they can flowing out is negative, minus 2, minus V1 minus V3, V1 minus V3 divided by 2, okay? Minus V1 minus V2, V1 minus V2 divided by 2 again equal to 0, right? Okay, we rearrange this equation first. Minus 4 minus V1 plus V3 minus V1 plus V2 equal to 0. Okay, then minus 2V1 plus V2 plus V3 equal to 4. Maybe we keep this equation. Node 2 2. KCL node number 2. V1 minus V2 divided by 2, right? Flowing out minus I, we don't know I yet, minus V2 divided by 4 equal to 0. We rearrange, multiply by 4. 2V1 minus 2V2 minus 4I minus V2 equal to 0. Then we have 2V1 minus 3V2 minus 4I equal to 0. This is equation 2. Node 3. Node 3 is IR1 is V1 minus V3 divided by 2 plus I minus V3 divided by 3 equal to 0. So we multiply by 6, right? 6 is will be 6 is 3V1 minus 3V3 plus 6I minus 2V3 equal to 0. Then 3V1, this is minus 5V3 plus 6I equal to 0. This equation number 3. And we cannot solve 3 equations with how many unknown? V1, V2, V3. But we don't know I. Okay? We need to remove I by these 2 equations. Right? And we will get 2 equations, 3 unknown. We cannot solve it again. Right? But we can draw what relation. We know that V3 minus V2 equal to 3 volt. We have equation number 4. Okay. So anyway, you're convenient. You can remove I first, right? By equation 2 and 3, right? You remove I, you will get another one equation, right? Without I. Then now you get 3 equations, right? Or anyway, any method. Maybe you can solve faster than me. It's up to you. Or you can solve 4 equations, 4 unknown, right? See that we are trying to solve 4 equations, 4 unknown. Okay? 4 equations, 4 unknown. You can remove the unknown one by one. Okay, any method you prefer. Okay. And there is some method that in the book that already solve it without method. You can try to solve by your own way and check whether you get the same value or not. Finally, we also get I, right? Finally, we also get I, which is current flow to the voltage source. So if the voltage source is there, maybe the computation is a bit more complex like this. Okay. they remove. In this case, you also can substitute V2 by V3 by 3 plus V2. You use 3 plus V2, substitute V2 plus T here. V2 plus T, right? You will get 3 unknown, 3 equations, right? So you can solve with any many ways to solve, right? Many ways. Okay. I suggest you to solve by yourself and check with the solution. Okay? You can do the different way, but finally you come to the same value, right? The same answer, right? You get the same answer. Okay, any question? Question is, can we finish now? Okay, maybe today we come to equation analysis. It's too hard to start today. Maybe you will need some time to analyze, to make analysis inside your own, right? Understanding, right? Today is maybe more than enough. Okay? Then see you next week, right? Okay, we may come to this room directly. So at least I think this slide, we will finish this slide and maybe also with the next slide, and the detail will be only up to what we have learned next week. Okay? Happy? Okay? See you next week.